So first we got to figure out how this deck is going to work. We have a platform here, which is a concrete platform. We're going to do a 4-inch slab on there. Now with that, we do not have joists. Okay, there are no joists. But when you think of this concrete slab, so we're going to have something sitting here, but this is a big mass of concrete. What is holding that big mass of concrete up?
Which one?
Right here, this big mass of concrete.
The
Metal.
pillars,
The column.
this, yeah, the columns.
Okay, the columns are, now there's gonna have to be a beam right here, right? To hold up this side of it. And then, and then we'll just put a little ledger and we'll bear this side on this building, correct? Now, as you look at it, this stuff isn't beam design and column design. None of this stuff is really rocket science work, but it's something you need to be pretty confident in. And we're going to do a lot of beam and column and footing design over the next few days. My goal here is not that you're able to do that work. My goal is that you are able to converse with the people you are working with, because this is the work they're meant to do, right? The engineers. Then you communicate that design. When you get into firms, if you get very good at this, they'll give you the job to do. It's not that hard to do. But you do need to have some experience and make sure, because if you get one of these wrong, what's the potential? Yeah, it can be pretty catastrophic. And I don't think any of us want to go to bed at night thinking that I made a mistake and it cost somebody a leg or whatever the case might be, right? So make sure you feel confident in doing this stuff. Like again, my goal is just so you feel you're used to the terms, you see how it goes about. Nobody's waving a magic wand here. In essence, we're going to use math to predict how this is going to work. Okay. So we've got a big mass of concrete. We've got to hold it up. That concrete, as we look at it, if I look at it in cross section, I'm 10 feet this way, right? And if I'm looking at it in this section, I'm 10 feet, I'm going to be 4 inches this way. Now, I've also got to deal with this on top of it. Okay? Maybe a chair or two, something of that nature. Okay? Now, does it make sense when you're looking at this thing right here? We know we have a reaction force right here. Okay? That reaction force is on the building. Okay? Do we need to calculate this R value here? No, we've got an existing concrete wall we're going to place this on. Out here, I have my column, okay, which will be the reaction force of the column. So in essence, weight here will transfer through the slab to the beam, and then to the column, and then to the ground. We're going to design the concrete to take that weight and spread it out in the ground at the very bottom.
More expensive on, I mean, would it be like heavier by the columns?
You got to look at each column individually, and no, it will not be heavier next to the column. Okay. That's where all the weight's going to go to, is the column. But in essence, it's all the same weight. Okay. So the way we're going to do this is we've got to figure out first how much weight is going to this column. Because if I'm going to draw a free body diagram of this, my footing. Okay, so I'm going to draw my footing here. Now on the footing, I need to have reaction of the soil. Should have made that a subscript. Okay. Right? Now, what do I have pushing down on this thing? Okay. Well, first, I have my column, right? Is pushing down. Then I have my concrete deck, which is putting down weight of concrete. And lastly, I have this person, which is the weight of live load. This is weight of column. Okay. So in essence, that's all the weight that the footing sees right there. If we know all of this, we can add it all up and figure it. Do we know the weight of the column? Yeah, we're going to use 8" by 8" by quarter HSS. We can calculate that weight. Do we know the weight of the concrete? Yes, we do. I just gave it to you. Okay. We're going to use concrete. We're not using reinforced concrete up here, so it's 145 pounds per cubic foot. The people. What do you have to use here? This comes out of the UVC because we don't know how many people are really on there. This is kind of a variable. You have to use 60 pounds per square foot for a deck for live load. Now, we're not really sure exactly of all these things right here because, we've spec'd this out, but, we're maybe 10 feet high. We don't know the exact height, right? We're going to put some slope on it, whatever the case. We've got to know this thing. But we can also use a value for this. You can use, if you're residential, 10 pounds per square foot for dead load. But on decks, you want to bump this up. We're going to go 20 pounds per square foot for a deck because we're putting a masonry unit up there. If I was just using a standard wood deck, I'd stick with the 10. Okay? So anytime I get into masonry, I bump it up to 20 because the stuff's high. Now masonry can be tile, concrete, all of these things. Yes?
That's what I was wondering is the rails and the tiles, the flooring, is all of that part of dead load
Yes, it is.
calculation?
Mm-hmm. Yep. And so we're just going to go with a value of 20. Now, the thing we've got to really do here when we do design is you're looking at two different things. The footing, in essence, is getting a point load, which can be a little different where this is a continuous load, it's a square foot term. The dead load is a continuous force, but it's all being seen in one place on the footing. So we've got to quantify it a little bit. You get this from your plan view. Now I would suggest to you on column 1 that it sees the weight right here. Okay, that's the weight that that column sees. Why? Because I know there's a beam here, so does it make sense half the weight's going to this column, half the weight's going to this column? I'm pinning it on these two areas, so half the weight goes to the existing structure, half the weight comes to the beam. Okay, that makes sense? Again, just common sense. Okay. What we then do, since we know that and it's a rectangular shape, what we want to do is we want to take a 1 foot section in here, okay, where this is 1 foot wide, because we're going to make it easy. And as we run through these calculations, one thing I will always point out to you, never round down in structural calculations, ever. Always round up. Okay? If anything, you want to overbuild it. Okay. So we've got a 1 foot area right here. What's this distance right here? The width of this? 5 feet, right? What's the distance here? Okay, 13. I'm not going to use any decimals. I'm just going to run with it, and I'm always rounding up. Now, this is my dead load, right? And it's a square foot area deal. So we can now figure this out. Let me write the equation here that we're going to use. Okay, so the reaction of my footing has to be equal to my weight of dead load plus weight of live load. the weight of the dead load. It is equal to 20 pounds per foot cube. Or excuse me, square. That is times by it's an area term. Right, because we know that we have to be 20 pounds per square feet. That's out of the building code. Good thing is, this is squared, right? I need to get rid of those. So my weight of dead load is equal to what?
$130.
You sure?
No.
Oh,
1,300.
1,300. That sounds better.
Yeah, sorry.
Okay, so we know there's one value. Weight live load is equal to 60. And that's that same number. 13 times 5. That's going to be 3 times it. Let me know if I got my numbers wrong. Good number. Okay, so we add those together, we're at 200 pounds. Okay, so R of the soil must be equal to 5,200 pounds. Does that make sense? Sure. Now, normally at this point right here, I would put a factor of safety in. So when I calculated my reactionary force, I know it's got to be 5,200, and I would put a value on it like 1.4, and so then I would times that by it, and that would be what I design it for. When I'm dealing with this one, we are forced to use clay. Remember that from architectural? Without a soil sample test, you must use the bearing value of clay. Does everybody remember what that value was? You could go to a soils chart, or you can go to our foundation chapters. Let's go to that page just so you can see it. I'm on page 837. This is what we use for houses. But now this isn't a true soils chart, but this is showing the 1,500 for clay, 2,000 for a silty loam, which is what we really have around here unless you're in one of the river bottoms. And then for stronger stuff, that's more rock. Now, at the start of these chapters, I think they also had a soil chart where they talked about it somewhat. Yeah, they talk about it on the first 2 pages of the chapter. If you want to read in that a little bit more. All right, so now we're ready to size our footing. So how we size the footing, gotta erase this, is we now have, let me draw a free body diagram. I know I'm pushing down with 5,200 pounds. I know I'm pushing up, that is at 1,500. Now this is pounds per square foot. This is pounds per square foot. My soil is capable of this. How do I find the size of my footing? Well, if I know 1 square foot of this will carry 1,500 pounds, then I need enough square foot to handle that much weight. So if you take 5,200, divide it by 1,500, this is pounds and pounds, that's equal to what?
3.46.
3.46. And this is foot squared. My footing has to be such that the area of it on the bottom here has to be greater than 3.46. This is the minimum value. So now I just start thinking of it and say, well, what size do I want? If I did a rectangle, let me look at it in a plan view. If I did a rectangle that was 2 foot by 2 foot, what's my square footage? 4 foot. Is 4 foot greater than this? That will carry that weight. Can I come smaller? Yeah. Try 1 foot 6. 1.5 times 1.5. What do you get?
2.25.
Okay, so we can't use that one. That one's too small. What about 1 foot 9 inches? That would be 1.75 times 1.75.
3.0.
3.0. And we generally don't get smaller than every 3 inches or so on this. Okay, so let's just go straight to 2 foot on this thing. So we now know the footing at column 1. Okay, so we're going to put a footing right here. It's going to be 2 foot by 2 foot. Now, as a general rule, when you design the footings, and piers especially, is you generally want them all the same or fairly close to the same, because people have to frame all this stuff up, right? And if everyone's different, you're going to lose more money on the people building the frames than you will for the concrete filling it. A lot of people in design, what they'll do is they'll look at the worst case scenario, figure out that footing, and everything else will get in it. In this one, I want 2 difference. Okay. And let me go back to this. Any questions on what we did here? We figured out the weight coming down, and then we figured out the square area needed to disperse that weight into the soil. Okay. All right, so as we looked at this, we did that area. Are there any other beams out there, or columns, excuse me, that have that exact same scenario?
Number 6.
Okay, 6 has actually got less, but pretty close, right? Because this distance goes to 7.5 feet versus the 12. So will this footing right here work for that? You bet it will. Okay. What about this one?
No,
This one's going to be this shape, right here. And in fact, it's actually going to be that shape. Well, we know we're at 7.5 plus 5 is 12.5. That's the same as we had here. But this one's going to be a little bit more because it's 5 there and 5 there. That guy's going to require a different one. Now, it still may be 2 by 2 because we had 3.46, right? Maybe you come up with 3.75 or something. It's going to be a little larger, the force coming down on it. But you still may be able to use the same size. Should we figure it out real quick? Okay, let's do that. Okay. So we know that this is 7.5 feet, right? That's 5 feet. This section right here is 5 feet. That's 5 feet. Okay, so run up your area and the weight. So dead load's 20, live load's 60, right? So let's just add them together. I'm gonna say 80 times, this is 5 times 12 and a half. 5 times 12.5. That's plus 80 times 5 times 5. So there's my numbers. Should be somewhere a little bit over 6,000 pounds. Maybe upwards of 7.
I
Yeah,
got
I got
7.
7,000.
You got 7 even?
Yeah.
So we're 7K. Divide that by 1,500.
4.66.
That's foot squared, right? So the 2-footer is not going to work here. Please look at incremental inches, every 3 inches. Okay. So 2 foot 3 inch footing square would be 2.25 times 2.25. What do you get on that one, Sean?
5.0.
Okay, and that pumps you 5.0, almost 30% above. Okay. You recommend the size on it? Now you're going 2 foot 3, right? At a minimum on that? Two foot 3 inches. Now we know this guy right here has to be 2 foot square. Is beam 2 about the same as beam 5?
It's a little bigger.
It's going to be a little bigger. Okay. So this guy is going to be something, now this is going to be the largest of, got my sign the wrong way. This will be the largest of column 1, 2, 5, and 6. What I'd like you to do is calculate the weight on column 2 and size that footing, and then use it for those 4, 1, 2, 5, and 6. This is going to be the biggest one right here, right? Because its area is going to be equal to that. Right there. That's going to be one size of footing. Then, I want you to use another size for 3 and 4. I would like you to do your calculations for beams 3 and 4 on a sheet of paper all by itself. Draw figures, work the math on it with a recommended footing size for a square footing on the bottom, and turn that in.
So just 3 and 4?
Just 3 and 4, that's all I want to see. Now, you should still calculate the size of footing 2, and I'll do it. And then tomorrow, if I forget, let's bring it up in lecture, so what everybody get. Okay?
Aren't 3 and 4 exactly the same?
3 and 4 are going to be the same.
So you just have to take
Yeah, they get the same footing. So I want,
You don't want number 2 on that paper?
no, I only want the calculation for 3 and 4, or 3 or 4.
You just want the calculation, or did you say you want the sketch?
Well, if you need sketches for free body diagrams and stuff that you want to do, you know, maybe I sketch rectangles because it's an area term, right? And write down all my numbers. When I do math, I do a lot of pictures. You know, so I basically do, remember, I just drew you a picture kind of like of this one, right? Where I did the rect area of that plus the area of that. And some pictures of those rectangles with dimensions on them might help you. Maybe you can sketch them right on here. I don't know, it's up to you. So, we're going to use the same footing for columns 1, 2, 5, and 6. And that will be based on number 2. Because that's got the most weight on it. And then you will have a separate footing for 3 and 4. And we're going to discuss those tomorrow. So what's your footing going to look like? Let's sketch it. We will have details of both of these, so if you want to start drawing them in CAD, you can. They're in essence going to be kind of identical. Let me go grab a black pen so it shows up a little better. Got one on my desk. I didn't have a black one. So we'll just